Good morning, everyone. First of all, I would like to thank again the ESPID organizer for inviting me to present this data, and most importantly, the scientific committee for supporting this work, which is around how could we improve our understanding regarding the role of respiratory viruses in inducing invasive pneumococcal disease dynamics. I did my first year of fellowship in Canada, in Montreal, and the second year in Paris, France. So I'm going to present some data coming from these two countries. So here are my conflict of interest. So as you know, Strep pneumoniae is a very frequent colonizer of the nasopharyngeal flora of young children. And in very few cases, this colonization can evolve to an invasive disease. And there is some evidence suggesting that respiratory viruses may play a role in this evolution from carriage to disease. And this data come particularly from epidemiological studies suggesting that there is a temporal association between respiratory viruses, and especially RSV and influenza, and invasive pneumococcal disease. But as you can see on this graph, there is a very important overlap between the seasonal patterns of all these respiratory viruses, making very challenging to really detangle the specific role of each viruses in inducing invasive disease. So in this context, our general hypothesis was that we could use the unique epidemiological situation following the pandemic of SARS-CoV-2 to try to better understanding this relationship between carriage viruses and IPD using the unique evolution and changes in epidemiology of respiratory viruses. So that was the main hypothesis of our work. And the first step of my presentation is about data from France, and Dr. Alexis Rybak, who did his PhD on this. So the first question was that we saw an IPD decrease, an unprecedented decrease in this disease. And the question was, what is the cause for this decrease? Is it related to changes in carriage and in transmission of pneumococcus, or is it more related to respiratory viruses? And to try to answer this question, we use multiple surveillance systems, and mainly national surveillance of carriage, respiratory viruses, and IPD. And we use the interrupted time series analysis approach to try to estimate the attributable fraction of IPD change that might be related to carriage or viruses. And so, very briefly, the main finding that was that, as in many countries, we observed, to graph to the left, the important decrease in IPD incidence in young children, but in the same time, absolutely no change in the overall carriage rate, and especially no change in the serotype distribution. So this allowed us to estimate the attributable fraction of IPD decrease that might be related to respiratory viruses, and found influenza and RSV were probably the main contributors to try to explain this decrease rather than pneumococcal carriage rate that remained quite unchanged. So first, when we decrease RSV and influenza circulation, we can decrease the IPD without any change in carriage. And then the second step was in Quebec. And when I arrived in Quebec, there was some changes in RSV circulation with a very important outbreak of RSV in November and December. And the question was, what was the consequences in terms of IPD incidence, and was it associated with an increase in IPD? So same approach, multiple surveillance systems, but in Quebec, of IPD and respiratory viruses, same statistical approach of interrupted time series analysis, and try to, again, to estimate the attributable fraction of IPD change, but this time of IPD increase. And what we found was that after a strong decrease of IPD incidence in young children, we observed a huge peak of IPD in children under 5, and this was strictly concomitant to the very important outbreak, out-season outbreak, because it was earlier than expected, of RSV circulation in the same population. And I was very lucky because RSV at that time was the only virus circulating, so that we could not demonstrate, but suggest that RSV was the main contributor to explain the IPD increase at that time. So second, when the RSV only increase in terms of circulation, we can see an increase in IPD incidence in young children. But this increase in IPD incidence was not the same for all age groups. And what we saw was that there is some age groups for which we did not saw the same magnitude of increase, and the question was, how could we explain that? And is it related to different pattern of respiratory viruses circulation across age groups, or change in carriage, or whatever? And so the third step of this demonstration was that what was the specific age-specific trend in terms of IPD and in terms of respiratory viruses. And then we were back in France, and again with Alexei Rybak. And the question was, can we correlate age-specific level of viral circulation with age-specific increase in terms of IPD incidence? So again, the same approach of multiple surveillance system, the same statistical analysis, I like that, interrupted time series analysis. And here, just to show you that in France also we observed an increase of IPD in young children, but not in other age group with the same magnitude. And we try to correlate the age-specific increase of IPD with the age-specific increase of RSV, influenza, and other respiratory viruses. And what we found was that the more the respiratory viruses increase in terms of circulation in specific age groups, the more we observed an increase in terms of IPD. And this was true for RSV, this was true for influenza, but also for metapneumovirus, but not for other respiratory viruses, suggesting that this specific correlation might not be true for all respiratory viruses, but more RSV, influenza, and metapneumovirus. So first, IPD can be reduced through change in terms of respiratory viruses circulation without any change in carriage. Second, IPD can increase again if viruses do so without, again, any change in carriage. And third, we can observe some dose response phenomenon regarding the level of respiratory circulation and the level of IPD increase, with a strong correlation between RSV, influenza, and IPD. So all this data suggests that RSV and influenza may be an important component of IPD epidemiology, and again, without affecting the ecological niche. So we are now in a unique position of being able to implement specific interventions targeting RSV, and hopefully it will also help fighting pneumococcal disease in the future. Thank you for your attention.